Course 3, Lesson 60, we are doing the area of a parallelogram. This will be a quick video. So first, when we look at the area of the parallelogram, we say that the area is equal to the base times height. This is just like doing a rectangle, but we need to make sure that when we find our base and height of the parallelogram, we use the length as our base. Height should be perpendicular to the base. This is because our parallelogram can actually be reformed into a rectangle. So we want to make sure that this height that we get that's perpendicular right here is actually the length of one of the sides of the rectangle. Okay, so just to show you that this does form a rectangle. So when we're finding the area and perimeter of the parallelogram, what we're going to be doing is saying if area is base times height, then our area is going to be, well, 30 is the base, that's the length of the side, and then we're multiplying it by the height, which is 17. Okay, that's the one that forms that rectangle. So our area should be 510, and it looks like we don't have units, so we'll say units squared. Now the perimeter here, we're going to be adding up 30 and 20. Okay, so in the perimeter we actually do use that slanted side, and we do have two of those. So we would say our perimeter is 100 units. For our next question, we have two different parallelograms here. We want to find the area and the perimeter of both of these. So our area is going to be, once again, base times height. So we are going to get 9 times, so we're not going to use the slanted, we use that 9 instead of 10, and we are going to multiply that by 11. So we get an area of 99 units squared. And for my perimeter, I'm going to be adding up 2 of the 11 plus 10s. So we're going to get a perimeter of 42 units. All right, for the right side one, we're going to get an area of 11 times 20. So our area is 220 units squared. And my perimeter, we're going to be doing, instead of using this 11, because that's not part of the parallelogram, we're going to be doing 2 of the 20 plus 12s. So our perimeter is 64 units. All right. Now let's look at this one. If we are given some coordinate points, it may form a parallelogram, and we can find the area using our units on the coordinate plane. So we're going to put A at 2, 1, B at 1, negative 1, C at negative 2, negative 1, and D at negative 1, 1. And so we do see that we form a parallelogram. And when we find the area of my original parallelogram, we're going to see that it is, well, 3 on the base times 2 on the height. So we get 6 units squared. And the perimeter here, we are going to get, well, 3 plus, it's going to actually be an irrational number. In this case, it's going to be the square root of 5. So we have 3 plus the square root of 5, and we have 2 of those. All right, we'll see and compare that to the bigger one that we do after doing a dilation of 3. So when we do that, we're just going to take all of my points and multiply them by 3. So we get 6 comma 3. We're going to get a b prime at 3 comma negative 3, and so on. So we plot it. Up here, we're going to get a prime, b prime is going to be here. C prime is going to be at 6, negative 3, and D prime is going to be at negative 3, 3. Okay, so it looks very similar, but just a lot bigger. And we see that the base of this is 1, 2, 3, 4, 5, 6, 7, 8, 9 by a height of, I'll go straight up here. So we have 1, 2, 3, 4, 5, 6. Okay, I know my lines are a little off. Hopefully you can see past that. So we see that my area, okay, of the prime is 9 times 6, or 54 units. And my perimeter is going to be Well, 2 of the 9 plus, well, if we have this, it's actually going to be a length of, let's see if I can do this in my head. 9 plus the square root of 45, which in actuality is 2 times 9 plus 3 root 5. When we look at the perimeters, it's actually all of the perimeter, especially that inside, is just multiplied by 3, which is good because our scale factor is multiplied by 3, is a multiple of 3. So the question is, does the area follow the same pattern? And you can see no. 6 times 3 does not give me 54, but 6 times 9 does. And if we see, our perimeter scale factor is 3, but our area scale factor is 9, which is 3 squared. When we go to an area scale factor, we actually square the original scale factor. All right, base and height of a parallelogram are always what? Perpendicular. And the area of this parallelogram, well, we would be doing 8 times 7, which is 56 inches squared. Now, let's compare a parallelogram that looks in 2 different ways. Now, these all have the same side length. That's 3 by 3 all the way around. And same here with this rhombus, 3 by 3 all the way around, which means that my perimeter for both is 12 centimeters. But as we can see, the area is going to be different. My area in the first one is 9 centimeters squared, while the area in the second one is actually 6 centimeters squared. Meaning that we might still have the same side lengths. If we squish that original square, squish it smaller and smaller, smaller, our area is going to get smaller and smaller. All right, find the area of a parallelogram with vertices at 4, 2, 2, negative 2, negative 2, negative 2, and 0, 2. So let me just pull a coordinate plane over so I can graph these a little bit easier. So we're going to have, I'll draw it. So we're going to have, let's say A at 4, 2, B at 2, negative 2, C at negative 2, negative 2, and D at 0, 2 up here. So we do have my parallelogram, which means that the base is 4 and the height is 4, which means my original area is 16 units squared. So what would the area of a dilation of this parallelogram be if we have a scale factor of 3? Well, just like we saw in the other one, if we have a perimeter scale factor of 3, my area scale factor is actually going to be 3 squared. So I'm going to have to take 16 and multiply it by 9 in order to get my new area, which in this case, let's see, that's 144 units squared, I believe, if I did my mental math correctly. All right, so we can use those scale factors pretty nicely. All right, and last one. A brass sculpture of the letter N is formed from one long metal parallelogram folded into 3 congruent parallelograms. What's the area of one of the smaller ones? And what's the total area of the long metal parallelogram? Well, the area of one is 4 by 6, so we get 24. And since we have 3 of them, we're going to say we have 72 feet squared. All right, well, I hope this is helpful for your homework and for studying.